Cascade parameters, we see how to derive cascade parameters. Now we go for determine cascade parameters for the network shown below. That is numerical problem make you transmission parameters or ABCD parameters or cascade parameters or chain parameters. Find cascade parameters for the network. It is consists of so many inductors, so many loops are there. To convert all these elements, we have to replace Laplace. Determine the cascade parameters for the network shown below. To find the cascade parameters for this network, the network is divided now into 3 parts or 2 parts based on our, it is one part like that. Convert all the elements into Laplace. How to convert resistor into resistor? L will be converted into Ls. 1 Henry will be connected to 1s. 2 Henrys means connected to 2s. Capacitor C equal to 1 by Cs. Remember this. The Laplace conversion of resistor is resistor R only. L can be 1s, 1 Henry means 1s, L is Ls. Suppose we have 2 Henry, 2s, we have to convert this into 2s. 1 Henry will be 1s, 2 Henrys means 2s. Capacitor 1 Farad is 1 by s, 1 by 2 Farad. 2 Farad in Laplace term we can convert 1 by 2s. Like that we have to convert. To find transmission parameters, first convert all these elements into Laplace transform. Then the circuit becomes like this. 2 ohm is 2 ohm. 2 Henry is 2s. It is 2s. And 2 Farad is 1 by 2s. 1 Farad is 1 by s. And 1 ohm is similar 1 ohm only. V1, V2. This circuit diagram we can redraw. Divide the network into 2 parts, network 1 and network 2. Network 1 consists of 2 ohm and 2s by 1 by 2s is one network, and another network is this one. Consider network 1, apply KVL for loop 1. KVL how to apply, we seen in first Z parameters also. KVL apply for loop 1. The transmission parameters equations are, first write the transmission parameters equations 1 and 2. V1 is AV2 minus BI2. After writing the transmission parameters, V1 equal to, apply KVL for loop 1, V1 equal to 2I1. The voltage drop here is 2I1 plus 1 by 2s into I1 plus I2. Assume all current directions are in same current direction, then we can add I1 plus I2. From that, you can write 2I1 plus 1 by 2s I1, 1 by 2s I2. Therefore, V1 is I1 made common, 2 plus 2, 1 by 2s plus I2, 1 by 2s. Make it as equation 3. Apply KVL for loop 2. If you apply KVL for this loop, V2 equal to 2s into I1, 2s into I2 plus 1 by 2s into I2 plus I1. V2 equal to, then you will get one equation. From equation 4, we can write 1 by 2s I1 equal to V2, send this term to this side, then V2 minus 2s plus 1 by s I2. From this, I1 only 1 by 2s we can send to that side, 2s into that one. Make it as equation number 6. Substitute in equation 3. This equation 6 is substitute in equation 3. That is I1. I1 in place of I1, you can substitute this. Therefore, substitute in equation 3, then you will get V1. After simplifying all this, you will get V1 equal to 4s plus 1 V2 minus 1 equation we get. From this equation, I1 equal to 2s V2 minus 21s square into I2. Now compare with equation 2, C equal to 2s, D equal to 4s square plus 1. Compare with equation 5 with equation 1, A equal to 4s plus 1, B equal to 8s square plus 2s plus 2. Compare equation 5 with 1, then you will get C and D parameters. Therefore, ABCD parameters you can calculate for network 1. For the network 2 also we have to do same thing. 1 ohm, 1 by S are in parallel. 1 and 1 by S are in parallel. Z equivalent we have to calculate. That is 1 into 1 by S by 1 plus S, 1 by S. Then Z equivalent is 1 by S plus 1 you will get. Therefore, the circuit becomes like this: 1 by S plus 1, I1, I2. Apply KVL for loop 1 or mesh 1, apply KVL for loop 2, then you will get V1 equal to I1 plus I2, 1 by S plus 1. Make it as equation 7. Apply KVL for mesh 2, V2 I1 plus I2, 1 by S plus 1. Make it as equation number 8. Now substitute this, send this side to this side, then 1 by S plus 1, V2 minus, send to this side, then you will get I1 equation. From this, compare this equation with equation 1, the equation 1, equation 2, compare this, C and D you will get. Compare this equation with equation 2, C equal to S plus 1, D equal to 1. Substitute V1 equal to 1 by S plus 1 in another equation, then you will get V2 plus 0 I2. Compare this equation, then you will get C, A and B parameters. After that, we have to add both the parameters, then you will get combined parameters, combined cascade parameters. Similarly, another problem we'll see now. Find cascade parameters or ABCD parameters. Let's see now. This one, H parameters, these are. Same, we assume that to find H transmission parameters, we are converting this into S domain. That is Laplace transform we have to apply for this. Determine transmission parameters in S domain for the network shown below. 1 ohm, 1 ohm, and 1 farad is there, that we have to replace with 1 by S. If inductor is there, that is S, 1S or 2S, like that. In S domain, equivalent circuit, all will be 1 by S. The capacitance C will be written as 1 by Cs, that is 1 farad is 1 by S, 2 farad is 2 by S. Step 1. By the definition of transmission line parameters, V1 equal to AV2 minus BI2. This equations already we remember. For every problem, we write the equations. After that, to find parameters A and C, I2 should be 0. This becomes 0. I2 should be 0 means this is open circuited. V2 is V2. Substitute I2 equal to 0 in equation 1. Then you will get A and C. Now apply KVL for loop 1. V1 is there. V1 equal to 1 into I1 plus 1 by S into I1. From that, V1 equal to I1 plus I1 by S. V1 equal to I1 into 1 plus S. From that, I1 equal to V1 by 1 plus S. V2 is the voltage across the capacitor, 1 farad. V2 equal to 1 by S I1. Substitute I1 here. This equation we are substituting here. V2 equal to, you will get V1 by S plus 1. Therefore, the parameters A equal to S plus 1. The parameter A, this is the big letter we have to write, A equal to S plus 1. Similarly, C equal to, at I1 by V2, at I2 equal to 0, I1 by V2 if you substitute, then C equal to S. Step 2, to find B and D, short circuit the output port. Output port is short circuited, V2 equal to 0. Then V2 equal to 0. Then we can apply another method, current division rule. Current division rule we have to apply. Ix equal to I total into opposite resistance by opposite resistance plus present branch resistance. That is B equal to minus V1 by I2. I2 equal to minus I1, 1 by S plus 1, like that you can write. I2 equal to this one, D equal to 1 by 1 plus S. Therefore, total impedance we can calculate, ABCD we can calculate. if you after calculation of transmission parameters, AD minus BC must be equal to 1. If you solve this, AB minus BC, you will get 1. That is about cascade parameters.